Okay, hello class. We're now on the third page of the notes, page 47, and we're going to be rotating about axes that are not the y-axis. So what that's going to do for us is it's going to change the radius a little bit, but we'll get to that in just a minute. So the first thing we're going to do is we're going to try to graph this. So we're going to find the volume of the solid obtained by rotating the region bounded by y equals x minus x squared and y equals 0 about the line x equals 2. So to graph this, here is, let's say 1, 2, 3, and I guess 4 will be over here. Here's our axis, which is x equals 2. And now y equals x minus x squared, it has a 0 at 0 and also a 0 at 1, because 1 minus 1 squared is 0. So it's an upside down parabola between those 2 points, so it does something like that, I bet. And when we spin it, notice we have that pivot foot idea, right? So this is going to swing all the way over to here. So we're going to get something like this. It's going to be like, I guess, top half of a donut, really, when you spin it all the way around. But what's important to us is the cylinder that we get. So let's pick an x value. The cylinder that we get when we rotate this is going to look something like this, right? Okay, so let's see if we can figure out how to set up the volume here. Well, it's going to be integral, and now you always go from the x bounds of the original region here, class. So 0 to 1, that's the original region here that we're spinning. And now we get 2 pi. I will leave a little bit of room for the radius, but the height of this cylinder is given exactly by the function, the height of the function, which is just x minus x squared. Now, the radius is where things get interesting for these problems. So you'll notice this is my x value here. The radius is not x, right? I'm not spinning about the y-axis. This is my radius, right? And that just so happens to be 2 minus x. You'll notice as x gets bigger, my radius gets smaller. So there's a minus relationship going on here. Okay, so now that we got that sorted, it's just a matter of expanding here. So we get integral 0 to 1, 2 pi. It looks like we're going to get 2x minus 2x squared minus x squared plus x to the third dx, which is equal to integral 0 to 1, 2 pi 2x minus 3x squared plus x cubed dx. And the antiderivative is then 2 pi x squared minus x cubed plus x to the 4 over 4, which simplifies. We plug in 1, and we're going to get 1 minus 1 plus 1/4. Plug in 0, everything vanishes. And so it looks like we're going to get pi over 2. Okay. So moving down here, you'll notice there's a typo. It says volume. Okay, so just pretend that's not there. All right, so let's find the volume of the solid obtained by rotating the region bounded by y equals x squared and y equals 2 minus x squared about the line x equals 1. So we've seen graphs like this before. So let's see here. X squared is just the normal standard parabola, I guess you would say. So it starts at 0, 0, and then kind of curves up in both directions. 2 minus x squared is the upside down parabola starting at height 2. So it looks like this is the region that we're going to get from -1 to 1. And now we are going to spin that about x equals 1. So this is our axis now. First thing you'd have to find, class, is actually where these functions meet. It is -1 and 1, but to verify that, you would solve this equation. So I'll leave you to verify that, but I would want to see that on a homework or an exam or something. Okay, now let's rotate this. So we'll turn over, I guess we do red first, so it kind of goes like this, and then like that. And so switching to blue, let's pick an x value. The cylinder that we're going to get has that height, and when we spin it, we get, well, okay, it's not the best drawing, admittedly, but it's going to look something like that, right? And so the volume will be given by integral x bounds of the region, which are -1 to 1, 2 pi, and now radius, well, let's see here. Our radius is not x, that is this length here. Our radius is 1 minus x, right? As x gets bigger, the radius gets smaller, so there's a minus relationship going on there. And now the height of the cylinder is given by the upper function, which is 2 minus x squared, minus the lower function, which is just x squared itself, dx. Okay, so what this simplifies to is the integral from -1 to 1, 2 pi 1 minus x times 2 minus 2x squared. And you got to do some foiling here. So this is, let's see, integral -1 to 1, 2 pi, we get 2 minus 2x squared minus 2x plus 2x cubed. So antiderivative is 2 pi out front. We get 2x minus 2 over 3 x cubed minus x squared plus x to the 4 over 2. And plug in 1, we get 2 minus 2/3 minus 1 plus 1/2. Plug in -1, so we get -2. -1 cubed is -1, so that's going to turn into a plus 2/3. Notice the double negative. -1 squared is 1, so we still have -1 here. And then we get plus 1/2 there. And let's see, so we're going to get a 2 minus a -2, which is 4. We're going to get a minus 2/3 minus another one is minus 4/3. -1 minus -1, actually those cancel, and 1/2 minus 1/2, those actually cancel as well. And so with a common denominator of 3, we're going to get, it looks like 8 over 3 times 2 pi, which is 16 pi over 3. Now you'll notice I left some room here on the side, and that's because what we need to do is set up the integral of rotating about the line x equals -1. So let's switch to green, and now let's, well, okay, good enough. Let's pretend we're rotating about x equals -1, this vertical line here. So now we're going to use this x value. I mean, we get pretty much the same image here, you know, when we spin it. And now using, let's say, this x value, the cylinder we're going to get now is this one here, right? So the volume will be still, we integrate over the x bounds of the region, so minus 1 to 1. We're always, those only come from the original region itself. So the graph that's in black here. 2 pi, now we need a radius. Well, if we observe here, for this x value, the radius is not x, that's this length here that I'm scrolling over between, but it's 1 plus x, right? The farther, or the bigger x gets, the farther I get away from my axis, so that's an addition. So it's x plus 1 or 1 plus x, however you want to write it. And now the upper and lower are still the same, so we get 2 minus x squared minus x squared dx. All right, and then I'll leave it for you to work that out. You're also going to get 16 pi over 3. That maybe shouldn't come as a surprise because like it's literally the same solid that you're getting, but the setup is definitely different. So just be mindful of that. Okay, in the next video, we're going to now use shell method to rotate about horizontal axes.